Hello, my name is Mike McGlone, and I am a NASA Curriculum Specialist with the Aerospace Education Services Project. I would like to share with you the activity Moon Rovers from the Summer of Innovation lesson plans on exploration. Can you imagine driving an all-terrain vehicle, or ATV, on another planet or moon? NASA can. It's building a fleet of ATVs, called Rovers, for future space exploration. Some can be driven by astronauts, like the Space Exploration Vehicle, or SEV, pictured above. Others are remote controlled. All of them can handle a variety of tough terrains. Talk about off-road adventure. Some rovers, such as the Mars rover pictured here, is robotic, with some autonomy and the ability to be controlled from Earth. In this activity, students will test and design a basic rover model. The basic design process is to design, build, then test your model while taking notes and data so you can analyze and redesign as needed. Each team will start with the same basic design or prototype, but through testing and redesign determine the best modifications to the prototype. A prototype is an early sample or model built to test a concept or process and can be used for testing and improvements before final production. The engineer pictured above is testing a prototype rover called Chariot. Today, you'll build and test a prototype rubber band-powered rover to test and improve. Working in teams of 2 to 3, students will build, test, and modify the prototype pictured here, a simple rubber band-powered rover. First, you will need to gather your supplies: cardboard, cut to specific sizes from the directions, rubber bands, straw, pencil, round one is best, candies, the small round ones with holes in the center, like lifesavers, plus rulers and tape. Let's start with the wheels. Use the 2 pieces of 5-inch per side square cardboard. Find the center by drawing lines between opposite corners. Set aside for now. Next, to form the chassis, fold the 6-inch per side piece of cardboard into thirds, about 2 inches for each segment. Be sure to fold along the ridges as pictured above and not across the corrugation to make it easier. Near one end of the chassis, poke a hole through each side. Be sure to line up the holes. To poke holes, a sharp pencil, an awl, or ice pick can be used, depending on the thickness of the cardboard. Remember, safety first. Now with a sharpened pencil, poke a hole through the center of one wheel, and push the pencil through that hole, the 2 holes in the chassis, and through the other wheel. Again, you might want to use an awl to make starter holes for the pencil. So now you have the wheels mounted. Be sure that the pencils spin freely in the chassis holes, but use a small piece of tape to secure the pencil to the wheels. If your cardboard chassis flexes, as shown here, and rubs against the wheels, put an extra rubber band around the chassis to keep it in shape. Next, for the rear wheels, tape the straw to the bottom near the opposite end of the chassis. Mount a candy on each end of the straw. Secure the wheels so they will not fall off the straw by bending the straw back and taping it in place. Now, as in the diagram, loop 2 rubber bands together in a chain. Loop one end around the pencil and secure the other end to 2 small slits you have cut in the chassis. Now you're ready to test the prototype. Wind up the rubber band by spinning the wheels, and when you set it down and let it go, see what happens. Depending on which way you wind the rubber band will determine which way the rover will move. As your rover moves across the floor or tabletop, did it make it all the way across? Observe how it performs. Ask lots of questions about why it moved in a certain way. Now you get a chance to change the rover and improve the motion. What would you change to make it work better? Have students develop a list of potential changes they can make. Remember that changing and testing one thing at a time is key to a successful project. Maybe changing the size, number, or type of rubber bands could make a difference. Have a variety of rubber bands available for students to use. Maybe changing the size or shape of the wheels could improve performance. Encourage students to test out many variations of the prototype to see which will perform the best, perhaps by crawling the furthest across the classroom floor. I hope you and your students enjoy building and testing these rover models. Good luck.